Hello friends, welcome in the Pharma Talks. And the today's topic is differences between the use of acetonitrile and methanol in a reverse phase chromatography. Okay, so as we all know, methanol and acetone or the organic acid commonly used as a mobile phase in reverse phase chromatography. So now we are going to discuss about the differences between acetonitrile and methanol. If we talk about the structure of acetonitrile, it is given here where the mouse pointer is pointed, and the methanol is here. If we talk about the chemical formula, so acetonitrile has a CH3Cn and the methanol formula is CH3OH. Acetonitrile is a non-protic solvent. So you guys know about what is the non-protic solvent and the protic solvent? Okay, I will tell you. A non-protic solvent is a type of a solvent which are unable to form a hydrogen bonding or any of the hydrogen atom is connected to the form the bonding in the electronegative atom. If we talk about the methanol is a protic solvent. Okay, and the protic solvent is those type of solvent which are capable of forming the hydrogen bonding and one of the hydrogen atom is connected to the electronegative atom. So here the formula of methanol CH3O at the electronegative atom is O and one of the hydrogen atom is connected to O. Okay, so on the second comparison data we have to discuss about the column pressure. Okay guys, so if we have to prepare a mobile phase, one is the water ACN mixture and the another is the water methanol mixture, and we have to inject in HPLC at a different temperature. The first one is the 40 degrees centigrade and the second is the 25 degrees centigrade. What we get? Okay, so now we have to discuss with the help of this graph by using the column ODS column 150 into 4.6 and 5 micron dimension column with the flow rate of 1 ml per minute. So if we use the water ACN mixture and we use at 40 degree and we use the water methanol mobile phase at 40 degree, what we get? The water methanol mixture has give the high pressure and the water ACN give the low pressure, and the same is true for the lower temperature also. So what is concluded? It is concluded that with the use of methanol we get a high pressure in our HPLC system, and if we use the acetonitrile we get the low pressure in HPLC system. So here I give it the point to acetonitrile because we all wants to work in a low pressure. Nobody wants the high pressure. Okay, so here my point is acetonitrile is a winner in the case of column pressure. Okay, now the next comparison topic is absorption spectra. Okay, so if we use the methanol as our solvent, we got what we got. We got a lot of interference in a lower wavelength side. If we use the methanol and you want to give the wavelength of 204 nanometer for your drug substance or drug product for the analysis, you got a lot of ghost peaks due to the use of methanol. If we talk about the ACN have a very low UV cutoff, that is 195 nanometer, and if the very low UV range, it can't give any. So if we talk about the illusion strength, so in water methanol ratio, if we prepare the water methanol ratio 40 and 60 and compared to that water ACN ratio of 40-60, so what we get if we have this compound methyl parabene, ethyl parabene, isopropyl parabene, and propyl parabene, and isopropyl parabene. So in methanol we get a separation very clearly, but in ACN all peaks comes clearly, but they are separate. So from this illusion strength we calculated the ACN mobile phase display greater illusion strength as compared to methanol. So again another topic for the comparison is separation selectivity. So separation selectivity is totally if we use the water ACM, if we use the acetonitrile or methanol, is totally depend on the column, totally depend on the molecule structure, what kind of molecule we have for analysis and what kind of selectivity it gives. So it totally depends upon the molecule. Okay, so like just see what I written here. The separation selectivity of acetonitrile and methanol differ, but since selectivity depend on the property of dissolved compound. So what is the dissolved compound? Dissolved compound is our what molecule which we have to analyze, which have to separate out. It is not the case that selectivity is always higher for one or other. So it is totally dependent on the molecule. So if we talk about the precipitation from the mixing with a buffer, so here what we got from the result is this table. If we prepare a mixture with ACN and buffer, we have a sodium phosphate buffer approx pH 2.6. If we prepare a 5 millimole solution, we got no buffer preparation. If we got a 10 millimolar solution, so we get the precipitation in 95:5 ratio, we got a precipitation. And if we got a 20 millimolar ratio, 20 millimole strength of buffer, we got a precipitation is 18:20 ratio. So all these here written here. If we prepare a sodium phosphate buffer approx pH 6.8, what we get in ACN, we get 1825 millimole buffer strength, we got the 18:20 ratio buffer deposition. Buffer precipitation on the 10 millimole buffer strength, we got the precipitation as 1725. So if we talk about the methanol, so it is rarely see that at the very high concentration of buffer strength, we got a buffer preparation only with the sodium phosphate buffer with a pH 6.8, we got the precipitation ratio of 18:20 and 100 millimole 70:30, and anywhere else we don't get any type of precipitation. Okay guys, so for in the case of precipitation, my vote is given to the methanol. Methanol is very well and very suitable if you have a problem for precipitation, so we recommended to use the methanol. Heat of reaction from the mixing with water. In the isocratic illusion, water and organic solvent are pre-mixed. Okay, so if we mix the water and methanol, what we get? We show a endothermic, we show a exothermic reaction. Exothermic reaction means in which heat is evolved. Okay, and if we talk about the water ACN mixture, what we get? If we mix the water and ACN, we get a endothermic reaction. In endothermic reaction, it cools the temperature. So from here we concluded that AC water methanol give the exothermic reaction which can increase the temperature of the mobile phase, and ACN which lower the temperature of the mobile phase. Why? Because the water methanol reaction gives the exothermic reaction and the water ACN reaction gives the endothermic reaction. If we talk about the cost, so methanol is cheaper than the acetonitrile, but so it is the total video where we have to compare the acetonitrile and methanol with the proper differentiation based on the few points. Okay, so please, if you like the video, subscribe the channel, and if you want more, just share it and comment on the video. Thank you very much.